any of the previous homework assignments? If not, yeah. We can look at 12. Problem number 12, the function that they gave us is f of x is equal to 1/2 x minus 3, and the function that we're applying to it is a reflection in the y, or in the x-axis. So our new function g of x is going to be negative f of x, because our reflection in the right x-axis, not y, x-axis in the general form is negative f of x. So, after we have it in the general form, we're going to replace or use our function with this here. Now, since we still have just f of x, we're going to replace f of x with its function, which will give us negative, parentheses, 1/2 x minus 3. Now, at this point here, we will need to distribute the negative through. So we're going to apply the negative to every single term. Now, most of the ones we did in the notes, we had the absolute values of the negative stayed in front, but here we're going to multiply that negative by the 1/2 x. So the negative, yes, is reflection across the x. So it's asking for the reflection across the x-axis, and the general form for it is negative f of x. Across the y-axis is our f of negative x. So that's where we got the negative from. The question was just part of the general form. Now once we replace it, we multiply. And lastly, our negative 3 gives us plus 3. So our answer for number 12.
I need the following students to report to room 10. Gio Acosta, Mason Roquel, Conley Hutton, Melanie Yang, Addison G.
Any other questions over the homework? Yeah. I think this is the equation given, yes? What is? Okay. Translation down to units. I'm thinking of 1.2. Different assignment. So, okay. And we're wanting to move it down 2. So the general form for this here, this movement, and we'll call the new one g of x, would be f of x plus k. And our k value for this here would be what? It would be 2. But it would be negative 2 because we're going down 2. If it's up 2, it's plus 2. If it's down, it's negative 2. Now at this point here, we can replace f of x with its function because it's still f of x, so we're so we'd have parentheses absolute value 4x plus 3 plus 2, and we have this here. Now we can drop the parentheses because there's nothing in front of it. And then we can combine like terms. Now, the 4x plus, the absolute value of 4x plus 3 is still going to be that there. We can't move anything inside of it. But we do have a positive plus 2 minus 2 on the outside, yes? So just the absolute value of 4x plus 3. That's it. Does that answer that question there? Because there's 1 or 2 where the number at the end ended up canceling out or simplifying out. It's gone. We good with those there? Okay. All right, we're going to go on and start with the notes today. So Harrison, we'll leave that alone for now so we can focus in. What we're talking about today is equations of a line. Equations of a line. Now there's three main ways we can write, well, two main ways we can write an equation of a line. Y equals mx plus b. That's the equation of a line. M is our slope, and b is the y-intercept. Because we did those in Algebra 1. I remember going over those with Miss Kendall, yes? Now, they named this equation the slope-intercept form because the two main parts of it are we have a slope and a y-intercept. So they called it slope-intercept form. Pretty imaginative, yes? They literally just called it what it was, slope-intercept form. The other one is point-slope form. The reason we call it point-slope is our y1, x1 is a point on the line, and m is the slope. So again, they named it exactly the way it is, exactly what it is. Now, if they give us the slope and a point, slope-point form is a great way to find the equation of a line. If they give us the slope and the y-intercept, we can use slope-intercept form. And really, it's not too hard to go from point-slope back to slope-intercept. The only thing we have to do is get the y value by itself and simplify the other side. Now, the other one is two-point form of the equation of a line. And I wouldn't write this down. If I were you, you can. I think two-point form is just more complicated than it absolutely has to be. It looks very similar to point-slope form. Y1 minus y1 is equal to y2 minus y1 over x2 minus x1 times x minus x1. What's the equation for slope? Y2 minus y1 over x2 minus x1. All we did was plug the equation for slope in for m for two-point form. There's no real reason, I think, to use that form. There's too much going on. It's too complicated. I think it's better to find our slope, which is y2 minus y1 over x2 minus x1, and then just plug it into point slope. Okay? As I throw a marker. But that's really the thing with all this here is we find the slope, find our point, and we can find the equation. Because to make a line, all we need is 2 points. If we have at least 2 points, we can graph a line. We can make a line. Any questions on this so far? Does anybody know why we use m for slope instead of s? Well, not so much, but most of mathematics, especially what we use, a lot of it wasn't English based. Because algebra actually comes from the Arabs, Middle East area. And the guy who came about it was from the term algebra, which means to complete, to return to wholeness. So algebra, that's where we get that from. Now, I think it is Latin or Greek, one of the two. Montaigne, mountain, increase, and increase, Montaigne, mountain. M is the best connection I've found that we're kind of going over why we have M for slope, because our term for mountain, Montaigne, is that increase in elevation. So they use M. But most of what we're going to be doing today is finding equations of lines and making predictions, making, well, calculations. Because here the graph shows the distance asteroid 2012 DA14 travels in X seconds. We want to write an equation of a line and interpret the slope. So it asks for two things. It wants us an equation of a line. So y equals mx plus b. Now when it says interpret the slope, words, what is the slope telling us about this function, about this equation? Now, the asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that distance of 17,200 miles? Okay? 3 parts of this. Find the equation of a line. Verbally or kind of in words, what is the slope telling us? And 3, how long does it take the asteroid to travel 17,200 miles? Okay. Now, they did give us a graph here. So the first thing, or one of the parts that we need to find, the equation of the line is the slope. Yes? So the slope, m, is equal to y2 minus y1 over x2 minus x1. We need 2 points. We have one, yes? 524. The y value would be 24. And the corresponding x value is 5. Because at any given point, x comes first, y comes second. X, y. So we don't have one listed, yes? Now looking at that graph, it might be easier to see on the board. Is there another point or spot on that line that it crosses nicely with an x and a y value, especially on that grid? Zero, zero, yes? Because at 1 is not a nice spot here. Yeah, not quite. So none of the other spots along the line, but 0, 0 is a nice point, yes? So we can use 0, 0. Now we can do this by hand. 24 minus 0 is 5 minus 0. Okay. It will be. It'll be 7.8. No, not 7.8. 4.8. Because 25 would be 5, so 4/8 or 4/5 would be 0.8. Or we can leave it as 24/5. And for most of these, especially when we start interpreting the slope, leaving it as 24/5 is going to be a little bit nicer. You can do it as a decimal. We can leave it as a fraction. Either one works. So we have our slope, yes? Let's go on and interpret it. So what it's telling us is distance and time in seconds, yes? So the bottom is, the 5 is time, the top is distance, yes? So 4, I can write over here, 4 every, what? Our amount of time, we're going over, yes? 5 seconds. Travels 24 miles. Let's make sure that's yep. Yeah, that works out fine because the only thing we would need to check and make sure is our graph itself. Because sometimes, especially on a graph, well, we're talking about thousands of miles or a bigger unit. And instead of having to write out 8,000, 16,000, 25, 24,000, we'll just say distance in thousands of miles. So we don't have to list it out as thousands. If you've seen the tachometer on your car, because it's 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 12, yes? In thousands. So instead of actually saying it's going 1,000 all the way up, they just put in thousands. It's easier to look at, it's easier to use if we're not using it in the thousands. Does that make sense? So sometimes, especially when interpreting, we just need to make sure that it's not talking about distance in thousands of miles, it's just distance in miles. So, found our slope. We interpreted the graph, or interpreted the slope here. Interpreting the slope. Done. Now we need to find the equation of the line, yes? We have two equations for it. We have point slope and slope intercept. We have the slope, so both of those work, yes? Do we have the y-intercept? Do we have the point where it crosses the y-axis? Well, yes. What is it? 0. So we can use y equals mx plus b. Because for us here, our slope we found to be 24 over 5. And the b value is the y value of the y-intercept. So it would be 0. Because the x value of the y-intercept will always be 0. Because that's the y-axis. The x value at the y-axis is always 0. We want the y value. Here, it worked out that the x and y were both 0. Now, we don't need to list that plus 0. So our equation is y equals 24 over 5x. Questions on this here? All right. We ready for the last part? Yes? So the last part was asking us to determine how long it would take to travel 17,200 miles. Yes? Yep. Now looking at this here, this equation, let's get a new color. X or Y, which one's our miles? Y. Y is our miles. So if I want to find out the time X, what do we need to do? I need to replace Y with 17,200. And now we need to do what? Solve for X, yes? So what would be our first step in solving for X? Well, we need to get X by itself, yes? So what can we do? So how are 24 over 5 and X, what is the operation between those two? How do I undo it? We can divide both sides by 24 over 5. Because we need to get it by itself. So we're going to divide both sides by 24 over 5. So 17,200 over 24 over 5 is 3,583.3 repeated. Or 3,583 and 1/3 seconds. How many of y'all would like to be able to travel that fast? It would be, because, I mean, we can kind of have some type of grasp that traveling 17,200 miles in 3,583 seconds, essentially, is a pretty quick speed, yes? Distance from here to Siloam is about what? 20 miles? Depending on how you go. Traveling at this speed, again, for every second you're traveling 24 miles. That means in under 5 seconds, you can get from here to Siloam. Yep. It'd be awesome, but that would also be an incredibly fast. It's traveling very, very quickly. If we divide this by 60, so that's our minutes. So I don't even think the circumference of the Earth, I don't remember it off the top of my head, but I believe it is less than 17,200 miles. You're going all the way around the Earth in an hour. Yeah. It is very, very quick. Do you feel comfortable with that last one? All right. The next one, the graph shows the remaining balance Y on a car loan after making X monthly payments. Write an equation of the line and interpret the slope and y-intercept. So we want to interpret the slope and y-intercept, kind of what it's telling us. And then we want to know what is the remaining balance after 36 payments. Okay, so this one has 4 parts. Well, defining the equation of the line, it might be helpful to know what the slope is, yes? Equation for slope, y2 minus y1 over x2 minus x1, change in y over the change in x. Now this one here gave us 2 nice points, yes? 0, 18 and 10, 15. Which one of those 2 points do we want to use first? 0, 18. So 18 would go first, and 0 would go first. Now, we would use our other point, 15 and 10. Whenever you're using 2 points, or whenever you're finding slope, whichever 2 points you use, whichever y value goes first, its corresponding x value has to go first. Whichever y value goes second, its corresponding x value has to go second. They have to match up. And the reason I say that is because distance formula, how we order the x and y doesn't matter. As long as the y's are together, x's are together. Midpoint, as long as the x's and y's are together, correct spot points, we're good. Here, order matters. Now, we just need to find these here, yes? So we'd have 3 over negative 10, which is negative 3/10. So we could say negative 3 over 10. We can say 3 over negative 10, or we can say negative 3 over 10. So I'll write those out. So we could say that it's negative 3 over 10 or negative 3/10. These are all the same. You just need to pick one. Normally, we either put the negative out front or on top. We don't normally leave a negative in the bottom. All of these are the same. So I just need one of them. I don't need all 3. I'm going to list all 3 out so that you're able to see it, know that they are the same, but I just need one of them. Okay. Let's interpret the slope. So the y value is the balance in what? Thousands of dollars, yes? The x value is our number of payments, yes? So we have negative 3/10, yes? So for every, what, 10 payments, what happens? The balance does what? Decreases by 3,000. So, is that a good thing? I'd hope so. Because what are we talking about here? This is what, a car loan. I hope your car loan's decreasing as you're paying it off. You're decreasing the amount owed. Yeah. Now, the value of a car is going to decrease because it'd be nice if it went up. Very rarely does it do that. But we have that there. Now, I also wanted the y-intercept. Now, the y-intercept is what? Is the original amount owed. Because that's what it started out. That's where whatever we owed on the car loan began. Because at the y-intercept, our x is 0, so the number of payments we made is 0. So it's however much we took the loan out for is our y-intercept. Does that make sense? All right. So, curve of the slope done. Y-intercept done. Now we need to find the equation of a line. Well, again, we have the y-intercept, yes? It's told us to be 0.18. So we can use y equals mx plus b. The slope was given to us as -3/10. And our b, the y value of the y-intercept is what? $18. So that there is the equation of a line. So since it gave us the y-intercept at 0, 18, it gives us the b value. So the equation is -3/10 x plus 18. Questions on any of this here? We good with all this here so far? Okay. Yes. So what's the last thing we need? Okay, so we need to know what's the remaining balance after 36 payments, yes? I heard two different things over that. So replace the y with 36. So what is x or y? Which one's the payments? The payments is x. So we're gonna, this time we're going to replace x with 36. So you're good. 10 times 36 plus 18, because again, this is something that they will input just seen because they'll switch from one to the other. The ACT is known for doing that. Also, make sure to check your units that they do line up. Because if for this here, our units, our x values are given in what? Number of payments, 36, so we're talking about most likely months, yes, or just payments in months. And the ACT will specify that. They'll give you your equation in one, and then they'll do this whole thing, number of payments per month. How much is the remaining balance after 2 years? Well, we can't just plug 2 in because the units don't line up. They don't match up. We'd have to correct that. Convert 2 years to 24 payments. But here, everything lines up. Now we just need to calculate this. There's 2 ways we can do it. The first one is we can do -3/10 times 36. and take whatever that amount is and add 18 to it, yes? Or -3 tenths, 36. So after we plug it in, we get 7.2, yes? So after 36 payments, the remaining balance is $7.20. Or is that not right? So 36 would be somewhere right here. What's the balance in? Thousands of dollars, yes? So it's not $7.20, it is $7,200. So the remaining balance is $7,200. Big difference there. Yeah, because if it was $7.20, you just pay it off. It also means that the original starting balance was at 18, would have been $18. There's absolutely no reason to wait. 36 payments would be 3 years, 12. No reason to wait. Yeah, no reason to do that. Well, any questions on any of this here? And the biggest thing I'd say with car loans, if you get a car loan or something like that, don't take more than 5 years, so 60 months. You run the risk of it going upside down. Being upside down on a car loan, house loan. You all know what that means. Upside down means you owe more than it's worth. And the biggest downside with that is if the car, you still owe $4,000 on the car and the car is only worth $3,000. If it gets in a wreck and they total it out, the insurance company will write you a check for $3,000. But your loan is $4,000. So you can use the $3,000, yeah, to pay the loan off or pay that part of it off. But you still owe another $1,000 on the loan. So you're paying on a car even though you don't have the car anymore. It's what they call upside down. And it stinks. You know, and that's the other downside is if you just pay it off and then the only thing worse that I've heard than that is buying it and then within a week totaling it. It hurts. No, not necessarily. Because an older vehicle, the more likelihood that you're going to have major repairs with it. So it's a give and take. I'd say the biggest thing is what are you planning on doing or using the car for? Is it something you're wanting to keep short term and not have a long investment on, or is it a car that you're planning on keeping for forever? Or essentially you're going to keep it till, yeah, you're going to run the wheels off the car. Essentially you're going to keep it till almost the next, or the big repair you're having to do is do a complete engine rebuild kind of deal. So then you're getting your money's worth. But neither here nor there. We will save this because I think we've got what? We can get this one done. The graph shows the distance. Allison hikes in X hours. Write an equation of a line and interpret the slope. And then we're going to determine how long it takes her to travel 14 miles at this rate. Slope. y2. Now they gave us a point, 24.5 and 7. Now the other nice point that we have is 0, 0. Yes, but we don't want to leave it as 24.5 over 7. We don't want a decimal and a fraction together. So we can plug into the calculator, and we do get 3.5 or 7.2. This one here, I'm going to use 3.5, just so we see the difference. One is a fraction. We've done one as a fraction already. Let's do this one as a decimal. So our slope is 3.5, yes? So, interpreting this slope for every how many hours? What's our time for this? So our slope is 3.5. Is there a denominator? So for every one, because it's, yeah, so for every hour, so we could say for every 1 hour, for every hour, she hikes how far? Miles. So if we convert it to a decimal, we're saying for every one of that. So for every 1 mile, for every one payment, this is how far it goes. Yep. Not too bad if you're walking, especially hiking up if it's up the hill. Now, do we have the y-intercept? 0, 0, yes? So it did tell us the y-intercept, the y value, our b is going to be 0. So we need to put the slope in, so y equals 3.5x plus 0, which is just going to be 3.5. So and the last thing is to find her, how long does it take her, her amount of time it takes to travel. Yeah, so 14 is equal to 3.5x. If we did have another value, something added to it, we would subtract it first. Then divide by 3.5. And that'll tell us x is equal to and that's it. We will finish this tomorrow.